So we've been asked to show algebraically that f of x and g of x are inverse functions of each other, so that f is g's inverse and g is f's inverse. Now, if this is true, if two functions are inverses, then f of g of x will equal g of f of x. Okay? So if they're inverses, then this composition f of g will equal this composition g of f. Okay? So what I like to do is I like to find f of g and I like to find g of f. And if they're equal, then these two functions have to be inverses. So I start with f of g of x. Okay? And I like to write that this way, which is f of g of x. Okay, it's the same thing, it's just written differently, which is f of g of x. Well, what is g of x? G of x is 1/2 x minus 2. So f of g of x is f of 1/2 x minus 2. So I take the function f of x here, and I plug in 1/2 x minus 2 everywhere I have x, which is 2 times 1/2 x minus 2 plus 4, which is x minus 1 minus 4 plus 4, which is x. Okay, so that's f of g of x. F of g of x is x. Okay, so now I have to find g of f of x, which is g of f of x, which is g of 2x plus 4. Okay, g of 2x plus 4. Well, g of 2x plus 4 is 1/2 times 2x plus 4 minus 2, which is x plus 2 minus 2, which is x. So g of f of x equals f of g of x. So then we go back to the original question. Are they inverses? Yes or no? And the answer is yes, they are inverses. Okay? So let's go to the next question. Same question. Are f and g inverses? Show algebraically if f and g are inverses. Okay? So what I'm going to do is I'm going to say f of g of x, which is f of g of x, which is f of, and g of x is here. So I'm going to plug that into the function f. So negative 1/4 x minus 2, which gives me, if I plug this function into this function everywhere I have x, I get 4. And then everywhere you have x, you put negative 1/4 x minus 2 plus 2. Okay? Distribute, we get negative x minus 8 plus 2, which gives me negative x minus 6. Okay? Now we're going to find g of f of x, which is g of f of x, which is g of, and we're going to put the function f in that parentheses, g of negative 4x plus 2. So you take the function g, and everywhere you have x, you're going to put the function f. Okay? So we're going to say negative 1/4 times negative 4x plus 2 minus 2. Okay? So then we multiply and we get, actually I see a mistake here. That's why I paused earlier. That's a negative 4. So that would be a positive x. But still we get x minus 6. Okay, so here we distribute this and we get positive x, and negative 1/4 times 2 is going to be negative 1/2, and then minus 2. And so I'm going to get x minus 2.5, or x minus 5/2, however you'd prefer to write that. It doesn't really matter. We'll write it like that. It's 5/2. Notice that f of g and g of f are not equal. So the question is, are they inverses? And the answer is no. They are not inverses. So that's how you show algebraically if f and g are inverses, is that if the composition of the two functions is the same in either direction, so f of g and g of f are both equal, then those two must be inverses. Okay? So if you have any questions, please let me know.